Welcome again. In this tutorial, we will learn how to combine more than one fuzzy rule to get a fuzzy output. In previous tutorial, we discussed how to form a rule and how to get fuzzy output out of that rule. Now, questions come, what if we have more than one rule for a particular situation? Then how to combine these rules into an output fuzzy set? Let's consider an example to better understand this problem. Here, we have given three partitions for input 1. You may call it as a partition K1, that is input 1, that is the vehicle speed is divided into small, medium and high, that is 3 partition. Similarly, 3 partition for the input 2, or you may call this partition as the K2, that is for the input 2 we have the engine load as small, medium and high. Again you can observe that we have 3 partition for the engine load, small, medium and high, and finally 3 partition for the output variable. The output variable here is emission, and again we have divided it into small, medium and high. So this compact graphical form can be represented using the following table, and this particular table is what we call as fuzzy associative memory, that is FAM, or the FAM table. And from this FAM table one can create a total of K1 multiplied by K2 rules, where K1 is the number of partition for the input 1 and K2 is the number of partition for the input 2. So in this particular example, how many rules we can form? As you can see that for the engine load we have 3 partition, small, medium and high, and for the vehicle speed again we have 3 partition, small, medium and high. So in total we can make 9 rules. As you can see in the FAM table that the green color indicates engine load as small, medium and high, and the red color indicates linguistic variable speed. So the output is given using the blue color. In total 9 rules are possible for this particular FAM. In an example, when engine load is small and vehicle speed is high, then the output, as you can see here, that is the emission is high. At this point you need not to worry on how we have formed this table. Frankly speaking, this information is usually gathered from domain experts and through literature survey. So in this example, we have chosen speed equals to 55.7, engine load equals to 55, and in order to illustrate how 2 AND rules are fired when one has chosen these 2 rules, or these 2 values in fact. So as you can see in input graph of speed, the rule number 1 is formed as when speed is medium. When I am saying that the speed is medium, that it means that we are talking at x equals to 55.7, which is we have given that we have chosen speed equals to 55.7. So at 55.7 the vertical line cuts triangle at membership value of 0.80, and the second variable, that is the engine load, is medium, that is at x equals to 55. Again we are given that the engine load is equals to 55. So at x equals to 55 the vertical line cuts triangle at membership value of equals to 1 in the load graph. Then what will be the emission? The emission is medium and the membership value will be 0.80. Why? This is because we know that this rule contains AND operator, and to get fuzzy output we can deploy min method. That is, we can take the min of 0.80 and 1, that comes out to be 0.80. Or in more detail, if I explain the calculation for the rule number 1, then we can say that when the speed is equals to medium, the membership grade is 0.80, and for the load equals to medium, the membership grade equals to 1. So the minimum of membership grade of 1 and the membership grade of 2 will be propagated to the output, as shown in the graph that y emission is 0.80. So again now consider the second rule. Again we are considering that at x equals to 55.7 and engine load when x equals to 55, that is medium, what could be the second rule? Now we can frame the second rule. When the second rule can be framed as when test is large, that is again x equals to 55.7, the membership value here is 0.30, and the load is medium, that is x equals to 55. The membership value for x equals to 55 in the load graph will be 1. Then emission is large. We come out the membership value of this emission in large set is 0.30. Then the final combined output is given, or you can show in the emission graph at the right hand side. We have just combined outer boundaries of each fired rule in the output graph to get the combined fuzzy output. Note that combining all different such rules is what we call as Mamdani system. That is, if you observe that in this particular formula, it is a combination of the max and the min operation, and the min operation is on the rules, on the particular rule that is being fired. So using this particular min operation, we are going to choose a particular output of that fired rule, and at the outside you are seeing that it is a max operation. It means that whatever the rules that are being fired, we are going to finally combine all these rules. That is, the final output, the final fuzzy output is the max of min of membership grades. Here, let me again explain you what does it mean by min in this particular formula. Here min operation reflects AND operator for each rule, and outside max operation indicates truncating outer boundaries of each fired rules and combining them or joining them together. If you look again on this example, here for the rule number 1, what was the rule number 1? That when the speed is medium, that is x equals to 55.7, the membership grade was 0.80, and the engine load is medium, that is when x equals to 55, the membership grade was 1. Then the emission is medium, that is the membership value is 0.80. We have deployed the min operation here in order to get this particular emission as medium with value 0.80. So this is the meaning of this particular internal min operation. Similarly, we will do for the second rule also. We deploy this min operation, and finally, in order to combine both rules into a single fuzzy graph, we deploy the max operation. That is, the max operation here simply truncates outer boundaries from each rule graph. Now, you tell how many rules will be formed if we choose speed value equals to 55.7 and the load value equals to 42.75. Again, you can choose this particular graph only. So, let me give you a hint, and rest will be for your practice. So, it is given that when the speed value is equals to 55.7, at 55.7, it will cut the speed graph at 2 points. As you can observe in the graph that at 55.7, the speed graph, the vertical line cut it at medium at 0.80, and at high it cut it at 0.30. For load equals to 42.7, it is given that for the load equals to 42.7, then you can observe that the vertical line will cut load graph at small equals to 0.30 and at medium equals to 0.75. So, before giving you a hint, let me tell you that when you are working on any attribute, always look for a value in the FEM table. Say, if the speed is medium and the load is small, then what is the value in the FEM table? Obviously, if you look in the FEM table, it will be small. So from this, we are very much sure that the output fuzzy value will fall in region bounded by small, but in order to calculate the actual value of this small, we need to apply any one of the min operation or max or product or sum minus product method that we have discussed in previous tutorials. Now, coming back to our example, you can formulate this following table. For this particular problem, as you can observe here that when the speed is medium and the load is small and you are deploying a AND operator, that is, you are going to form the rules using the AND operator, then how you are going to calculate the value? So when you say that when the speed is medium and the load is small and you look in the FAM table, then for speed equals to medium and load equals to small, the emission will be small. So we need to find the value of this particular small. How you are going to find the value of this particular small? Obviously you are going to deploy either min operation, max operation, sum minus product operation. So which particular operation you would like to do? As you know that here the operator is an AND operator, so we are going to deploy the min operation here. So we will take the min of 0.80 and 0.30, that comes to be 0.30. So when the speed is medium and the load is small, so we will have the emission at the small with a membership grade of 0.30. Similarly, you can go for the speed equals to high and load is equal to small. Then in looking into the FAM table, we are very much sure that on these two, the emission will be medium. But in order to find the value of this particular medium, we need to apply the operator, we need to apply the operation. Again, we are going to apply the min operation. Why min operation? Because this rule is concatenated using the AND operator. So similarly, for this particular situation, we can form these much rules. We can form 4 rules out of this. Now, after forming these rules, we are very much sure that for a particular rule, we have the particular emission as an output. For each rule, we have one output graph as an emission graph. And we can calculate, obviously in this particular table, we have calculated the values of each particular emission graph. So now finally, what we are going to do, we are going to combine these output into a single graph, single emission graph. So what we are going to do, again, as discussed before, we are going to take the outer boundaries from each graph. And how we are going to take the outer boundaries from each graph? Obviously, we are going to take the help of max operator that we had discussed just before. So in this quiz, out of total 9 possible rules are possible and only 4 rules are fired for a given value of the speed and load. So I hope you will be able to solve this quiz and come out with the final output graph after combining individual values from these particular rules. For each of the particular rule that is being fired, here 4 rules are fired. For each rule that is being fired, if we first calculate the emission value, we will see whether this particular fired rule fall in the small, fall in the medium or in the high region. If once we have decided, okay, this is going to fall in the small, then we are going to calculate its value by applying the min operation. And finally, we have the 4 graphs for each fired rule. And we are going to finally combine all these 4 graphs into a single graph. So this is left as an exercise for you, and how you are going to combine and using the max operation, and what will be the final value using this particular max operation on this particular final output graph for the emission. I hope you will be able to solve this quiz and be able to come out with the resultant fuzzified graph. In the next tutorial, we will discuss how to defuzify the output fuzzy graph obtained, and so that we can have a crisp value for making real-time judgments. Hope you understood how to make rule base and how rules are fired, and how we are going to combine different rules into single output fuzzy graphs, single output fuzzy graphs. So see you in the next tutorial. Till then, happy learning.